How do we work with inverses when we have infinite domains and targets, right? So here we have all the natural numbers. That's the integers from 0 to infinity. And that's both the domain and the target. What does that mean then to be able to do the inverse? Well, remember that first we have to define if it has both the onto and the one-to-one property. So with infinite sets, we can't just look at every case. So we have to look at enough cases. We have to find out, can we find one case or that breaks either onto or one-to-one? So let's just start working with this one for a while. So we know that we could write this out in a different way, right? So if I write this out, this is the domain. And we know that this is also the target, but what is the range? So let's just do a few to see what we get. So when x is 0, it maps to 0 plus 3, which is 3. When x is 1, it maps to 1 plus 3, which is 4. When x is 2, it maps to 2 plus 3, which is 5. And we can see this pattern going indefinitely, right? Infinitely. And so we see that this is the range. We just took each individual one and we see this is going to continue. So this is definitely one-to-one. For each value in x, we get a single value in y, and each value is different, right? So we won't ever have a value in the domain that maps to two values in the target. So it is absolutely one-to-one. Is it onto? Does every value, is the value in the range or in the target, is every value in there mapped to? And we look at this and we see, wait, what about 0 and 1 and 2? Are they ever mapped to? And it turns out they are not. If this is our domain, we will never be able to actually map to 0, 1, or 2. So this is not onto. There are some in the target that are not mapped to. So this doesn't have the property onto. So it doesn't have an inverse. And notice we just have to kind of think through and talk through kind of what does it mean to be infinite like this. Now, if we change this, watch what happens. If we change this to all integers, positive and negative, then does it work? Then can we get 0, 1, and 2? Sure, then we can get -3 is going to map, right? This is going to be all the values. -3, -2, -1. So these are all going to be, and it's going to be infinite this way as well. So our domain changes. Well, then what happens here? Well, we take -3 and we add 3 to it. We're going to get that 0. And we take -2 and we add 3 to it. We're going to get that 1. And we add -1 to 3, and we're going to get that 2. Right? So here we got all of the values we were missing before. But what about, can we go the other way? Can we continue to get numbers? How would we get -1? Well, we just start with -4, and that's in the domain. So we know we can get -1. Can we get -2? Yeah, we work with -5. So if we do -5 and we add 3, we're going to get -2. So here we can see that we can continue infinitely. And since we have all the negative numbers and all the positive numbers, we will ultimately get all of them. So now, theoretically, you can say if you could reach the last infinite negative number, we're going to add 3 to it, so we won't get those. But it turns out there is no end to the number. So there's always some negative number that we can add 3 to and come up with that negative number. So this one is both, so this one is one-to-one, right? Each value in the domain maps to a different value in the range. And it is also onto. So we're going to be able to map to every single value in the target. So we're going to come up with every single integer, all infinite number of them. So now we can do, this one does have an inverse. And the way that we do the inverse here, again, is we solve for y. So or solve for x. So we know that y equals x plus 3. That's what we've been doing, right? We've been doing it in our head. We've just been talking through it because that's so easy to map. We just substituted, put a 1 in here, and we found out the y, in that case, the y is 4. We put a 2 in here, and in that case, the y was a 5. So we know that that's the case. So now we can, now we want to solve for x. So I'm just going to swap these sides and solve for x. And so x equals y minus 3. All right, and that's our inverse. So now we take it to get the inverse. I'm just going to copy this down. What do we do for the inverse? Well, we have to label it with the minus 1. That is a superscript. And the domain and the target swap, they're both, you know, that they're both all the integers, right? The set z, which is all the integers. And now we just simply say, now y, f of y equals y minus 3. And that's the inverse. Now it turns out that what value you put here, what variable you here doesn't matter. So we could use c, right? And that's still the inverse of this function because it doesn't matter what value we use for the variable. And in fact, because we're just saying it's an element out of the domain. So take any element out of the domain and apply this function. You identify what the value it maps to in the target. And so we're saying take any value in the domain, which is any integer, and apply this function, and that tells you what it maps to in the target. So it doesn't matter which variable you use. So in fact, we could write it this way. So the inverse of this function is this function.